So now let's move to the chapter 3 about addressing it. Okay, you have the sum of the objective for this one. You know how to work with the MAC address, and media access, control address, or physical address, or layer 2 address. They have the same name. It has some name. Physical address, MAC address, layer 2 address. They are the same. And you know how to configure the TCP/IP setting on computer, including the IP address, the subnet mask, default gateway, and DNS server. And know how to identify port on several common network protocol and describe the domain name and the name resolution process, and use a command line tool to troubleshoot the common network problem here. Now, the first thing I want you to know about how the address works. So in order to do that, you have to understand the idea of the position location. So now we think about all of the normal on the daily activity. Normally, when we talk about the number, it is a base 10, right? It's a base 10 number. So what is the base 10 number? Base 10 number, that means if you have one digit, you have the 10 possibility. You have a 10 possibility here. So you have everything from 0 to 9. That is for one digit. You have the 10 possibility. That is the base 10, or they call it decimal system here, right? Decimal number system. So we think about this one. If I had the number 982 here. So how we break it down? You have to work on. Sorry. You have to work on the position notation. So basically, in the decimal system, you break it down in the one column here, right? And 10 column, 100 column, and 1,000 column, and so on. Right? So we see for each of the column, you have the specific value. For this one is the 1. This one is the 10. This one 100. This one is 1,000 here. And the reason that you have, the 1, you have the 10, 100, and 1,000 because here it is a decimal system. So you think about this one here. You have the base 10. Base 10 is everything from 0 to 9. Each digit, you have the 10 possibility, right? So you have base 10. And this is the base 10. And for the column 1, you raise to power of 0 here. You know that 10 raised to power of 0, you have 1. Right? And for this one, you move on. This one, you have the base 10 and raised to the power of 1. That's why we have the 10 here. Okay? And this one also, you move on the left. You have this one column here, you have base 10 and raised to power of 2, you have 100, and so on. This one, base 10 raised to power of 3, you have 1,000. Okay, so now if you look on the 982, actually it breaks it down in the notation here. Right, so see, what is the 4? Actually 4 here, you have the 4, you time it 1,000 here. 1,000 here, right? And this one, 900 here, you have 900, you time it to 100 here. And for the 80 here, for 8 here, you have the 8, you time it to 10 here because it is the 10 here, right? And the last one, you have the 2, you time it to 1 here. So we see, you have 4,000, you have 900, you have 80, and you have 2, and when you sum it up together, you have a 4,982 here. That is the way you work with the notation, position notation here. Right? So now, this one is applied exactly the same when you work with the binary system or the base 2 system here. You know that for the computer, it works on the binary system or the base 2 system here. And the reason it works with the base 2 system because for every computer, you have a million of switches. Right? When it's on, that means you have number 1, and off, you have number 0 here. So now, if you look on the binary system here, remember for binary system, for each digit, you only have 2 possibilities here, only 0 and 1. 0 and 1 away. That's why they call it the base 2 here. Base 2 for each digit, only have the 2 possibilities here. And it do the same with the notation. With the positional notation here. You see, for this one, you have base 2, you raise to power of 0. And so on, you have a base 2, you raise to power of 1, you raise 2, you raise to power 2, and so on here. Okay, so see, raise to the power 0, you have 1, you have 2, you have 4, you have 8, 16, 32, 64, and 128 here, right? So basically for the binary system, for every 8 bits, each of the digits, they call it the bit here. They call it the bit. And they group every 8 bit together, they call it the 1 byte. 1 byte. So you have 8 bits. You have 8 bits, you have 1 byte. And group everything from 0 to 7, that means you have the 8 bit here. So we see. So in order to convert it from the binary to the decimal and decimal to binary, it's very simple here. The thing about if I have this one here, if I have the binary number here, 1 1 0 1 0 0 all of the 0 here. So how it works, right? You can break it down in the positional notation here. So this one's the 1, right? And the value of this column is 128. So we time together, you have 128 here. Okay, and this one you have 1 here, and the column, the value column for this one is 64. That's why you have 64 here, right? And all of them here, you have 0. That's why you have 0. You have 0 here, all of them 0. And after that's all, you just sum up together. You convert it 1 1, and the 60 here, you have 192 here. It makes sense? Okay. So now think about this one. If I have the number of 1 0 0 1 1 0 1 0 here, so what do you think? What is the decimal number of the binary number 1 0 0 1 1 0 1 0 here? What is the decimal number for this one? What do you think? Come on, guys. I see many of you online, but I don't see any interaction here.
Is it 128 plus 0 plus 0 plus 16 plus 8 plus 0 plus 2 plus 0?
Yeah, right. So what is it? 154. 154, right? Okay, 154. So see, you have this one 128, right? And you have this one, it's a 16 here. You have this one, you have 8 here. And this one, you have 2 here. And you just add them up together, right? So 128 and 16 here. What 16 here? What do you have? 144, right? 144 with 8, you have 152, and 2 here, you have 154 here. That is correct here. Okay, so that it, in order to convert it from the binary to the decimal, you always have to understand the positional number here, right? So we have to know this one is number 1, 2, 4, 8, 16, 32, 64, and 128, and so on. Okay. Now, and that is the way you convert it, right? That is the way you convert from the binary to decimal here, right? And now, how will you convert from the decimal to binary? How we convert from the decimal to binary? And the way you convert it, you have to follow the process here. You have to follow process. Think about, you have the 8 bit here. This one is the 1 byte here, right? This one 1 byte. And that means you have the 8 bit here. Okay, so see, if you have 8 bits, the minimum value is all of them 0 here, right? All of them 0. And the maximum value is all of them number 1 here. Okay, so see, if you have 8 number 0 here, when you convert it to decimal, you have number 0. And you have 8 number 1 here, when you convert it to decimal, you have 255 here. Right? So that's why you see the maximum value of 1 byte is in the decimal, the minimum is 0, and the maximum is 255 here. Okay, 255 here. So now, if you want to convert from the decimal to the binary, you have to follow the process. You see, you have the positional number here: 1, 2, 4, 8, 16, 32, 64, and 128 here. Right? So now, if you want to convert, so think about if you want to convert from 171 here to the decimal. So you have start from the left to the right. Right? So see, the first thing you compare here, 171 You compare to 128, you need it. You need 128 here. That's why you put the number 1 here. So see, when you already have the number 1 here, you have to minus it. You have to minus to the number 1. That means you have to minus for 128 here. So what you have left? You have 49 left. You have 49 left. So now you see, you have 49 left. You have moved to the right here. Okay, this one 64, and you have 49. You don't need 64 to make it up for the 49, right? That's why you put 0 here. You don't need it, otherwise greater than. So when you see this number is less than, you put 0. Right? So now move on. For the 49 here, you need the 32 for this one. Right? Greater than, you put number 1 here. And of course, when you have to put number 1, you have to minus 32 here. So you need the 17 left. Okay? You need the 17 left. Move it to the right. Yeah. For the 17, you need 16. You need 16 here. That's why you need the number 1 here. And of course, you have to minus the 16. You have only 1 left. You don't need this one. You don't need this one. You don't need this one. And you need number 1 here to make it to the 172. Sorry, 171 here. Okay, that is the way you convert it from the decimal to the binary here. Remember that you always have to remember the positional notation here. That's the first thing. And you move everything from the left to the right. When you have greater than, put number 1. You have less than, you put number 0, and so on. It makes sense?
Yeah, that makes sense.
Okay. Any question? Hello?
Not so far.
Okay. Okay, so in the computer also, you have one of the another system is the hexadecimal. Hexadecimal here. So for hexa that means 16. That means 16 here. That is a hexadecimal. You have the hexadecimal. Hexa that means 16. So that means for one digit, you have a 16 possibility. And it's everything from 0 here. You see, you have a 0, everything from 0 to 9, you will have 10. So we have A, that means you have number 10. You have B, number 11 here. You can think about A here 10, B here 11, and C here 12, and D here 13, and E, you have 14, and F, you have 15. So we see, if you have everything from 0 to 15, you have the 16 possibility. You have the 16 possibility. And for the 16 possibility here, you have everything from 0 to 9, A, B, C, D, E, and F here. Okay, now think about this one. If you have the 16th possibility here, if you have the 16th possibility, what do you think? How many bits you need to represent for the 16th possibility? What do you think? How many bits you need? How many bits you need?
8.
3. Okay, now see. 3. Now let's see. You have 0, 0, 0. You have 0, 0, 1. You have 0, 1, 0. You have 0, 1, 1. And you have 1, 0, 0. You have 1, 0, 1. You have 1, 1, 0. And you have 1, sorry. And you have 1, 1, and 1 here. You only have 8 possibility only. If you need the 3 bit. Right? You see? If you have 3 bits, 1, 2, 3, 4, 5, 6, 7, 8. Not enough. Right? So if you want to represent for 16 possibility here, how many bits? What do you think? 4, right? And you have the formula here. You have formula here. You have 2 raised to k here. That is the power here. Right? So think about if you have 1 bit, you have 1 bit, you have 2 possibilities, 0 and 1. And if you have 4 bits, you have 4 possibilities here. 2 raised to power 2, you have 4. You can have 0, 0, 0, 1, 1, 0, and 1 and 1. And you have a 3 bits, you have 8 possibilities here. Right? And that's why you see, if you want to represent for 1 hexa here, if you want to represent for 1 hexa here, you need 4 bits here. You need some 4 bits. And you see, 4 bits here. You can see, sorry. You can see from this one here. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? And you see everything from 0, 0, 0 all over to the one here. Okay, so now remember that in order to present one hexadigit, you need 4 bits here. It makes sense?
Yeah.
Okay. Okay, so now you know how to convert from the decimal to the binary, from binary to decimal. You understand that for the hexadigit, for one hexadigit, you need a 4 bit, right? And you can convert here for the F, you convert it to the 1111, the E, you convert it to 110, and so on here. Now, that is a major part of this one here. Okay, so this is the way you represent for IPv6. I will talk about it later, not now. Now you move to the IP. Sorry, you move to the address overview here. Normally, you have the four addressing methods. The first one is data link layer or media access control address. That's the first thing. So this one here. The code's name is data link MAC address, or they call it MAC address here. MAC address or physical address. Physical address or layer 2 address. That's it. So whenever I talk about the MAC address or physical address or layer 2 address or data link here. Data link layer, data link address, they are the same. Right? So whenever sometimes I mention the MAC address or physical address or layer 2 or data link layer address. They are the same. And all of them, they have the 48 bit here. And the 48 bit here. But the 48 bit here, it represents on the hexadecimal, not the binary. Okay, represent the hexadecimal. So what do you think? If you have 48 bit here, how many hexadecimal you need to represent the 48 bit? How many hexadecimal? How many hexadecimal you need to represent for 80 bits?
Is it 8? Or sorry.
Is it
No,
3?
it's not.
No?
4.
Now, come back, right? You see, in order to represent for
Is
one
it
hex-
6?
No? Okay, let me explain it again. In order to present one hexadigit, you need 4 bits. Is that noted, right? In order to represent one hexadigit, you need 4 bits here. So now you have 48 bits. So what is it? How many hexadigits you need?
12?
Yeah, 12, right? Because every 4 bit you have one hexa. That's why you have the 48 bit here. You need the 12 hexadigit. That's all. So remember one thing here. Yeah, remember one thing here. MAC address, physical address, layer 2 address, and data link address. It is represented by the hexadigit, and it needs 12 hexadigit here. Okay, so now let me see what is the hexadigit here. Let me see hexadigit. So basically, for every network interface card, every network interface card, that NIC here. NIC is where you want to interface with the network, right? When you want to connect to the internet here. So for every network interface card, you need the 48 bit here, or you need the 12 hexadigit here. Now you can check your network interface card by the command here. You go to the command prompt. Right? And you put the IP config and space and /o here. So you see, this one is where I connect to internet, and you see, I have a physical address here. You see, if you look at this one, I have a physical address here. So I have a 2, I have 4, I have 6, I have 8, I have 10, and I have 12. I have the 12 hexadigit for my network interface card, or physical address, or MAC address, or layer 2 address, or data link address. You can check by your own yourself. Each one of you only have the you only have the physical address here. And remember one thing here. Remember one thing. This one only unique. You never ever found the two network interface card have the same number here. Right? It already identify you. Okay, that's the first thing you have to remember. This one here, you have the 12 hexadecimal, and it is unique. Okay, that is the first thing you have to remember about the layer 2 address or the MAC address here. Okay, again, for the 48 bit or the 12 hexa here, you have this one. You have the 48 bit, right? You have the 48 bit, and break it down into two portions. It break it down in two portions. You have 24 bit for the first one, and you have the 24 bit for the second one. That means you have 6 hexadecimal for the first one, and you have the 6 hexadecimal for the second one here. So for this one, I can break it down here. I have the first 6 one here and the second 6 one here. Okay. Now for the first 6 hexadecimal or the first 24 bit here, they call it is OUI. OUI. And the second one, they call it is a serial number here. So what is OUI? OUI is organizational unit identifier. So by looking at OUI, you can tell what is the vendor, what is the manufacturer of the interface card here. It can be, if you can look it up, you can see how it is. That is a Cisco, or it is a Microsoft, or it's a Dell. You can look it up by the first 24 bit here. Now see, if I have the let me go here, right? So we see for this one, I have the first 6 digit here. I just copy it. Copy it here. Control V. Right? Now I can go to the web and insert it up and go with the OUI. OUI lookup. Right? So I just paste this one here. I click the path. So you see, it tells me that this one it is manufactured by Dell. Dell is a vendor here. Right? So my interface card it manufactured is the Dell company here. Okay, so that remember that for the MAC address, in total you have the 48 bits. That means you have the 12 hexadecimal. It breaks it down into two portions. The first 24 bit or the first 6 digit, it is OUI or the vendor here. The second one is serial number within the vendor. So we see if you have the Cisco for this one, the serial number here is uniquely identified the device manufactured by Cisco here. And when you combine both of the two portions together, you always have the unique MAC address. You never ever have the same MAC address here. Okay. Okay, so this one here, sometimes they call it is what is it? It is a hardcore that is burn-in. Sorry, yeah, burn-in address. They call it by EDI here, burn-in address, and it's a hardcore in the ROM, and you are not able to change it here. You can think about the MAC address here is the name. You can think about the name. It's same with the name here, and it stays the same during the whole life. It's always the same. Okay. Now come back to this one. That is the first thing I want to mention about you. The first thing is the data link layer or MAC address layer or physical address or data link address. They have a 48 bit, right? 12 hexadecimal. Break it down in the OUI and serial number here. That's the first thing here. Now the second one is a network layer address, IP address here. It's not the same with the MAC address here. It's not the same with physical here. The network layer address or internet IP address here. You can have a two version of that. You can have the IP version 4 or you can have an IP version 6 here. For IP version 4, you have the 32 bit. For IP version 6, you have the 130 bit here. For IP version 4, it breaks it down in the 4 group, and each group you have the 8 bit. They call it the octet here. And for the IPv6, it's written in the hexadecimal. Okay, it breaks it down into the 8 group, and each group you have the 4 hexadecimal here. Okay, let me come back to the slide here. Where my IP address? I don't have IP address here. Okay, now we can think about this one. Remember, for IP version 4, you have the 32 bit. For IP version 4, you have the 32 bits. And you break it down into 4 groups. You have 1, you have 2, you have 3, and you have 4 here. Each group, you have 8 bits. You have 8 bits here. And 8 bits. So on. It's great, right? So you see, for 8 here, when you convert it to decimal, when you convert every 8 bits here to decimal, what is the minimum value? What do you think?
0.
Yes, 0. Right? What is the maximum value?
255.
255, right? Yeah, 255. That's why you see, when you see the IP address, you see something about 172.65.10.5 here. It breaks it down into 4 groups, and each value in the group here in the range everything from the 0 to 255. Right? That is the IP version 4, 32 bit. Break it down in 4 groups. Each group is the 8 bit here. And to make it simple, normally they convert it into the decimal here. To make it simple here, right? 173.65.1.5 here. And of course, when you convert it to the binary, you have 8 bit for this one, you have 8 bit for this one, 8 bits for this one, and 8 bit for this one. Okay? That is IP version 4. Now, for the IP version 6, for IP version 6, again, you have 128 bit here. You have 128 bit, not the 32 here. And 128 bits, it represents, you see, every 4 bit you have 1 hexadecimal. Right? Every 4 bit you have 1 hexadecimal. That's why if you have 128 bits, you divide by group of 4, you need the 32 hexadecimal. Okay, now for the 32 hexadecimal, they break it down into 8 group here. I see you have 1, you have 2, 3, 4, 5, 6, 7, and 8 here. Right? When you break it down into 8 groups, that means each of them you need the 4 hexadecimal. In the 4 hexa here, you need the 4 hexa. So that's why you see you have everything from 0, 0, 0 to F here. And in order to separate between the group, they have used the column here. They use the column here. That's why you see something about the IP version 6 address here. Any questions so far?
No, this is making sense.
Okay, so now, right now you know that you already know the 2 type address here. The first one is physical address, and the second one is the IP address here. So some of you raise the question here. Why do you need both of the IP? Why do you need both of the IP address and the physical address? What do you think? Why do you need both of the physical address and the IP address? Why you don't need only one physical address, or why you not only the IP address here? What do you think?
Because, while the physical address like lets you know which computer it is, the IP address lets you know like who on the network is pinging or something, or trying to get.
Yeah, that makes sense. Now, to make it simple, let me give you an example here. To make it simple, let me give you an example here. Okay, so think about this one. You want to send the email. Sorry, not email. You want to send a letter from you to your friend. Right? You want to send a letter here. So what do you have to put it in the letter here? You have to put your name, right? You think about this one, David here. Right? From the David, from this one from here, and this one too here. To Michelle here. Name, right? Okay. Besides the name, what do we need? Address also, right? A house, right? So we think about 110 sheet and Bloomington here, right? Bloomington IN here. And you send to this one here in 220 sheet and Chicago here. Right? So here, you can think about this one. David here and Michelle here. You can think it is a physical address. You can think this is a physical address here. It's a physical address. You can think about this one. It's physical address here. It always stays the same. Even that you move to the San Francisco or you move to the China or Spain, whatever it is. So name is always the same. The same is the network interface card here. Even that you bring your computer to your home or you move to the another location, it always stays the same with the MAC address here. But see, for the IP address here, the IP address here is changeable. It's changeable, right? So we see in the address here, when you move from Chicago to San Francisco, it's not 210 sheet or Chicago anymore. It can be the 1500 or anything here. IP address is changeable. IP address is changeable. The same when you can think about when you live in the house and when you change the apartment, the address change here. Okay, that's why you see for everything when you in order to communicate with the computer on the network here, you always have to use a combination of both of the physical address and the IP address here. You can think about that physical address is your name, and the IP address is your house address here, and it's changeable. Okay, that's why you have to use a combination of both of the address here. Okay, now think about this one. Sometimes you only need the physical address here. That means when I code your name here, I don't have, I want to send you the letter. I just write out the name. I don't need the address here because you and me on the same class here. That's why when you communicate on the same network here, you only need the physical address. But whenever you go beyond the network, you only have to import the IP address here. You have to tell what is the address here. Okay, it makes sense.
Yeah.
So that is the reason that you have to remember that you only have to use a combination of both of the physical address and the IP address here. Now we move to the third one. The third one is a transport layer port that you to find the application. So as I mentioned it before, right? As I mentioned it before here. So you can think about this one here. You can think about this one. You have the computer here. You have the one computer. Right? And you only have one cable connection. You only have one cable connection to the internet here. Right? Now see, on the computer here, you share everything with a single physical connection, but you might have a multiple logical connection here. One for the World Wide Web here, right? And one for the email service, right? Or one for the file transfer protocol here. You might have a multiple logical connection on one physical here. So how can you identify which traffic belong to, let's think about this one, which traffic belong to the World Wide Web and which traffic belong to the email and which traffic belong to the file transfer protocol here. In order to do that, you have to use the port number. You have to use the port number, and the port number is addressed in the transport layer here. So when you see everything with the port 80 here, you know that is the World Wide Web traffic. And you have the port number of 25 here, you know that is traffic of email. And you have the port number of 21 here, you know that is the traffic of file transfer protocol here. All right, so make sense?
Yeah, for the most part, yeah.
You use the port number to tell you what application it is, because at the same time, you might have multiple applications running on the single physical connection here.
And that'll like tell you exactly where to send it to, right?
Yes. Right.
Okay, thank you.
And the last one is a computer name or host name here. That you configure it locally on the computer. Okay, so that I already mentioned about the
I can only see a blank white screen. I don't see anything else.
Oh, sorry. Okay. Okay now.
Yeah,
We're
can
good,
see,
yeah.
Yes, thank you.
So just I mention it again for the MAC address, you have the 48 bit, right? Break it down in the first 24 bit is the organizational unique identifier, and the second one is the serial number or device ID here. Okay, so see, let me talk about in the case we mentioned about that. In the case of the same network, right? In the case of the same network, you can directly communicate together by using the MAC address here. You are the same network. You don't need to invoke the IP address here. Right? So here the thing is that you can see on this one here, the two right here. They are on the same network and they directly communicate together by the switch here. And remember that the switch here is a layer 2 device. Layer 2 device. That what is it? Layer 2 device. That means it only understands about the layer 2 address or the MAC address. You have not. The switch here, it has nothing to do with the IP address here. The switch is layer 2 and the IP address is layer 3 here. Right? So that's why the switch never ever understand what's going on with the IP address. It only understands about the MAC address here or physical address here. So say in the case of the same network, or I want to talk it to you, I want to write the letter to you, I just write the name only. I don't need IP address for you, right? So see for this one, I can put here, I want to send some message from the sender to receiver. I put the MAC address here, right? I put the MAC address here, that is the source and that is destination. And they forward to the switch and the switch know this PC here connected to the F0/1 and the switch just forward it to the F0/1 and so on with on the same network here. You only need to use the MAC address in the case on the same network here. And you see, you have 1, sorry, you have 2, you have 4, you have 6, you have 8, you have 12, 10, and you have 12 here. Okay, so to make it simple, let me show you some of the simulation here. You should understand more about this one. Okay, so now if you look on this topology, they are on the same network. On the same network, they interconnect them together by the switch here. By the switch here. Now see, if I want to ping from the PC1 to the PC2 here, PC1 is 192.168.1.10, and PC2 is 192.168.1.20 here. Let's see what is going on here. So in order to do that, the switch they maintain something they call the MAC address table. It knows which port connected to the PC here. Okay, so right now, if you look on the switch, right now, by the command here, show MAC address table, you don't see anything here. So right now the switch don't understand which computer connected to which port here. They have no idea for that one, right? So next, let's go with I work with this one, and I want to use the simulation here. I want to generate here. So now see what happened here. This is ICMP message. That is ICMP message. So let me capture this one. Let me reset it. Okay. Oh, maybe I have not is I have not set the IP address. Yeah, I have not set it. Sorry. 192.168.1.10. Okay, now see what happened here. We'll talk about this later. Let me come back to this. Come back to this one. Delete it. Okay, so now this is ICMP. ICMP, the first one, the ARP. You don't need to understand what the ARP now right now. So see, now if you look on the ICMP message here, when you click on this one, you see, it clearly understand. It clearly tells you that the switch have no idea what is the layer 3, layer 4, layer 5, layer 6, or layer 7. The only thing that switch understand is that layer 3, sorry, layer 2 address here, or MAC address, or physical address here. You see, you want to send it here. You want to send it. Okay, so see, 6 EED here, it is from the PC1, and he want to send it to 1D07. 1D07, it is this guy here. And so see, in the case of in the same network here, in the case of when you send it to switch have no idea what is the IP address. So all he knows is a MAC address here, and he knows that this guy here connect to the port F0/01, and this guy here connect to the port F0/2, right? So that's why when we send it to the switch knows that in order to deliver to the 1D07 here, he have to forward it to the port F0/2 here. Let me go with this one to see what is the port. You see, this one is port 0/1, and this one is port 0/2. So see, this guy here, 6 EED come from the port F0/1, and this guy here, 1D07 come from the port F0/2, right? So that's why when it send it to switch forward it to the port F0/2 here. You can see it here. Click on this one, it forward it to exactly the port F0/2 only. It never ever forward it to the F0/3 and F0/4 here. And the reason the switch knows that we got right now, the switch understands that we have the MAC address table here. He understands that this MAC address here matching with the port F0/1, and this MAC address here matching with the port F0/2. I see everything switch do is everything about the layer 2 only. You have no idea what is the IP address here. And that's why it's on the same network here. Okay? It makes sense?
Yeah.
Okay.
Yes.
Okay, so the same is this one here. You see, in order to communicate on the same network here, you need to involve the source MAC address and the destination MAC address. And when you forward to the switch maintains this MAC address table, and he knows that this port here matching with F0/1, and he knows that this one here matching with F0/2. So when he look in this one, when you look on this one, he knows that he has to forward into the F0/2. Okay. Now we move the IP address. The IP address, right? The IP address, we have the two versions, IP version 4 and IP version 6. IP version 4 is the 32 bits, and IP version 6 is the 100 bit here. 32 bit, break it down in 4 groups. Each group you have the 8 bit here. Right? For each 8 bit, when you convert to the decimal, you have everything from 0 to 55 here. Right? And for each group here, it's separated by the dot here. 56.105.12 here. Okay, so we also have the definition about the class 4 address and the class 4 address here. Okay, so I think for this one to understand it a long way here, so let me make it brief here. So basically for the IP address, you have something about the IP address here, 32 bit. That's the IP address. IP address. Version 4. And you have one definition. It is subnet mask here. Subnet mask. Subnet mask also 32 bit. Subnet mask also we have the 32 bit. But the difference between the IP address and subnet mask is that the subnet mask it tell you how for the IP address here. Right? Sorry, I come back to this one. For the IP address here, again they break it down in two portions. They break it down into two portions. The first one they call it the network portion, and the second one they call it the host portion. They call it the host portion. They break it down in two portions: network portion and host portion. And in order to tell you how many bits belong to the network portion and how many bits belong to the host portion, you have to understand the definition of the subnet mask. Subnet mask again, the same with the IP address, 32 bit. But for in the subnet mask here, every bit in the network portion, you have bit number 1. You have bit number 1. And every bit in the host portion here, you have bit number 0. So see, if I look into the subnet mask, you can understand that you have how many bits in the network portion and how many bits in the host portion here. Now think about this one. If I have the subnet mask here, 1.1.1, and you have A0 here. So if you look at this one, what do you think? How many bits in the network portion and how many bits in the host portion you have for this one? For this subnet mask here, you have 8 here, you have 8 here, and you have 8 here, and you have 8 here. So what do you think? If I have the subnet mask of H number 1 here, H number 1 here, and H number 0 here.
255.
Now, my question is that how many bits belong to the network portion and how many bits belong to the host portion?
16 and 16.
No, not 16 and 16.
You said the first two each have 8. I thought.
You see, you have the 3 group of number 1. Can you see my screen? Hello?
Yeah, we can see
Yeah.
the screen.
Yeah. So we
So
have
the first 3 belong to the net.
yeah, right. All of
Oh,
them.
okay. So the first 3. So that's not 8. I mean, okay.
So that means you have 24 bits. You have 8.
Yeah.
Yeah. That means you have 24 bits in the network portion, and you only have the 8 bits in the host portion. So the subnet mask here, by looking into the subnet mask, remember every bit in the network portion you have bit number 1, and every bit in the host portion you have number 0. Right? So in the subnet mask also, when you convert it to the subnet mask, when you convert it into the decimal, right? You can convert it to decimal. You have 255 for this one, you have 255 for this one, you have 255 for this one, and you have 0 for this one. Okay? Or you have one, you can represent by the slash notation also. You can use this one here, slash 24 here. So when you look in the slash 24, you understand that you have 24 bits in the network portion, and you only have 8 bits here in the host portion. Okay, that is definition of the subnet mask. We know that why you need the subnet mask. The subnet mask tell you how many bits in the network portion and how many bits in the host portion, and it can tell you that if the 2 computers here on the same network or not. It can tell you. Right? So now let me give you another example here. If I have the IP address here, 192.168.1.10, and I have another computer here, 192.168.1, sorry, not .1, .2 here, .2.20 here, and this one /24, and this one /24. Now, my question is that, what do you think? If the 2 PC here, A and B, they are on the same network or not? Remember, the 2 computers on the same network, only they have the same network portion here. They have the same network portion here. So what do you think? If you look at PCA and PCB here, PCA 192.168.1.10 and PCB 192.168.2.20, both of them have the 24 bits in the network portion. /24, that means 24 bits. So what do you think? They are on the same network or not?
No,
Why?
No.
Why?
because of the 1 and the 2 in the third bracket.
Yeah, right. See, if you have the slot 24, that means you have the 24 bit here in the network portion, right? So we have 192.168.1 here. That is the network portion of a PCA. And this one here, 192.168.2 here is the network portion. You see, 1 here and 2 here is not on the same, not the same network here. So they are not on the same network. So see, in the case they are not on the same network, you cannot directly communicate together. You need to involve the router here. All right, the router is the one who interconnect the network together. Now, let me come back to my simulation here. You can understand how it works with this one here. Now, so back then, you see, you come back to my computer here. I can use a ping here. Oh, I have to go here. That's it. I ping it here. 192.168.1.30. So see, I want to ping from 192.168.1.10 to the 192.168.1.20. Both of them slash 24. That means they are on the same network. Right? Because both of them, they have the network portion is 192.168.1 here, 192.168.1 here. I'm able to connect together. Now, what happened here? If I change the IP address for this one, I change it to number 2 here. You see, when I change it to number 2, they are not on the same network anymore. This one is 192.168.1, and this one is 192.168.2 here. Change it to here. Okay, now see, when they are not on the same network, so even that they are directly communicate together with the switch here, you are not able to ping it anymore. You are not able to ping it anymore. All right, you see, stay there. It's not able to ping it anymore. So you see, when you study about the IP address, you have to understand the definition and the underlying meaning of the what is the IP address and what is the subnet mask here. You see, come out here. Even that they directly communicate, directly connected together by the switch here. But the IP address here, 192.168.1 network, 192.168.2 network, you are not able to ping anymore. You're not able to communicate together anymore. You have to involve the router for this one. It makes sense?
Yeah.
Yeah.
Okay, so now we all know the idea. Know the idea of the subnet mask, right? Subnet mask, that means something about slash here. Slash 24. That means you have 24 bit in the network portion, or the 24 and 8 bit in the hot portion here. Now, what is the class 4 address? The class 4 address is something that you stop at the boundary of. Okay, so what is it? You have here. You have 8 bit here. You have 8 bit here. You have 8 bit here, and you have 8 bit here, right? So the class 4 address, that means you have the slash 8 here, or you can have the slash 16 here, or you can have the slash 24 here. So that is you have the boundary at the back here. You have the slash at the boundary. Right? That is when you have the class 4 address here. So normally you have the class A, class B, and class C. It is for the public IP address. That means you are able to go to the internet here. So for slash A, for class A, you have slash 8 here. Class B, you have slash 16 here, and class C, you have the slash 24 here. Class A, what is it? If slash 8, that means for the network here, you only have the 8 bit in the network portion, and you have the 24 bit in the host portion. Now, if you think about the network with the 24 bit in the network portion, you see, when the 24 bit is the network portion, in total, you have the 2 raised to power of 24, you have about 16 million. You have about 16 million ports in the network. That's why the class A here, you for a very, very huge network here, huge network. Now, you have the class B. Class B is a slash 16. That means you have the 16 bit in the network portion, and you have the 16 bit in the network, in the whole portion. So for this one, you have the 2 raised to power of 16. You have about the 65,000 computer on the network, it's a huge network here. And the class C here, class C is the most common network. You see, the most common network. You have class C here. You have the 24-bit in the network portion, and you will have the 8-bit here in the whole portion. So with the 8-bit here, you have the 2 raised to the power of 8. You have about 256 IP address in the network. Okay, that is small network here. Nobody using in the local area network here. Okay, that is the definition of the class 4. Remember that class 4 you can slot at 8, slot at 16, or slot at 24 here. Okay, and also you have the class C. So sorry, class D and class E also. We talk about what is class E and class D here. Sorry, yeah. Oh, I'm not mentioned it here. I think I should mention it later. Wow. So in order to use it with the public IP address here, you need to you have the class A or class B or class C is a licensed IP address available to you in the internet here. They call it is a public IP address. So what is the class A? Class A is always starting with the first bit is 0 here. Always starting with the first bit is 0. 0 here. First bit of the 24-bit is 0, and you have the slot 8 here. So that's why you see for the first octet here, you can have 0, 1 over to the 0, 1, 1, 1, 1 here. All of them 1. That's why when you convert it to decimal, the class A here always starting from 0 to the 127 for the first octet. So we see something about 126 dot something dot something dot something. You know that is a class A address here because it's in the range from 0 to 127. So now that is the class A. And for the class B, the first 2 digit is the first digit here. What is it? 0, 1. Yes, it has the first 2 digit is 0, 1 here. 0, 1 here. And of course, we have the first 2 digit here. You can have the 6 bit 0 and the 6 bit here, number 1. And when you convert it to decimal, you have everything from 128 to 190, 172 here. 190, yeah, 191 here. 191 here. So we see everything in the range from the 128 to 191. It is class B. And the class C, you have the first 3 bits here. It's a 1, 1, and 0. And of course, after that, you have 0 or 1 here. So everything from the 192 to 223, you have the class C here. Okay, so this one here. So basically, in the IP address, again, they break it down into 2 types of IP address. They break it down in 2 types of IP address. The first one is a public IP address, and the second one is private IP address. Public IP address, that means it's routable. You can go to anywhere in the internet. It's a public, you can go anywhere. You can go anywhere in the IP address. And the public here, it must be unique. Unique. It must be unique, and you can go anywhere in the internet. And the second one, you can use the private here. Private, you can reuse it. You can reuse it. But the thing is that private, you cannot go to the internet here. It only contains it in your network only. So you see, if you look on the computer, you see a lot of you will see something about 192, 168, not something here. Not something here. They are private IP address. So even that my computer at my home is a 192.168.1.5, and your computer also 192.168.1.5. Even that they are same, but they are private IP address. It only contained in your network only. It never go beyond the internet here. And in order to go to internet, you have to translate it. You have to translate it from the private IP address to the public here. Okay. And you see, the reason they use the private here, they want to save the IP address. They want to save the IP address here. And if you look on the IP version 4 here, you see, if you look on in the IP version 4, you have the 32 bits of IP address, right? 32 bits of IP address. So totally, in the total, you have the 2 raised to the power of the 32. You have about 4 billion IP address. Only 4 billion. And nowadays not enough. Right? Nowadays not enough. That's why if you use everyone with the public IP address, you cannot have enough IP address. That's why you have to use a private IP address here. The reason they use a private IP address because they can reuse it. They can reuse it here. And remember that in order to go to the internet, you have to convert from the private. You have to convert to the public here. And the reason that you can save it because you can use a 100 private IP address. You just need to translate it to one public only. You can save a lot of IP address. Right, so we see normally you see at your home or in the campus here, you see everything in the range here. So you have the 3 range of the private IP address here. The first one is the 10. So we see 10 dot everything here. It is a private IP address. And the second one is the 172.16 come all over to 172.31. It is the second range of the private IP address. And the third one, you see, mostly you can see as the home address here, right? 192.168.0.0. So everything is starting with the 192.168 here. That is the third range of the private IP address here. Make sense? Any question?
No.
No question.
I think that is for the today. Let me see what you have for the homework. This one. Okay, this one here. This one you have to do with the packet chaser, right? And remember that in this one you have to submit both of the file here. You have to submit the Word file and you have to submit the complete packet chaser file. So this one is the Capstone project 3.2.
Oh, can I ask about the assignment you just showed?
Yes.
I'm just making sure because I was looking at it a little bit earlier. We just create our own network, right? Or does it like?
Yeah. Right.
Okay.
Capstone 3.2, right? Yes, this one. And you have to build the MAC address table. MAC address table in the packet chaser. Right? Open the packet chaser, right? I see. You have to build your own topology. You have to follow this one, right? In device network device and click the switch and the PT switch to the workspace here. So for this one. Okay, so you have to work with the switch. You have the PT switch here. Right? Just follow it. Exactly the same. You have to follow it and you have to build your own topology. Okay. Okay, so we see the show MAC address table here. The show MAC address table is that in matching between the MAC address and the port number. Right? See the same with the example I just gave you. The matching between the MAC address table here. Yeah, so we have the one switch and you have the 2 computer and you have to configure the IP address for the computer and the switch also. Anyway, we still have a lot of time. You try to do it by yourself, and if you have any challenge, you come back to me on Monday. Okay. Okay, so that remind you again, the private IP address only contained in the local area network only. So anytime if you want to go to the internet, you always have to translate from the private IP address to the public IP address here. And in order to do that, you have to use the network address translation here. It's a technique designed to conserve public IP address that need for the network. And you know that the main reason you use the private IP address is that you want to save public IP address here. Right? And the address translation is a process where the gateway device substitutes the private address with its own public IP address here. That is the process of translate from the private to the public here. Right? And you can have some of the technique here. It can be port address translation, or it can be the source address translation, or dynamic network address translation here. So here, let me tell you the reason that you use a private IP address is that you want to save the public IP address, right? So think about you have a network here. Think about you have the network here. In the network, you have the multiple port for the switch, and you connect it to the multiple computer here. You have the multiple computer here. So think about this one. You have 192.168.1.10, and you have this one 192.168.1.11, and this one 192.168.1.12. Right? And for this, it's a local network. It connects to the gateway. It's a router here. And remember that the router is the one who interconnects the network together. And whenever you want to go to the internet, you have to involve the router here, right? So here you can think of the router here. It is a gateway. They call it the gateway here. Gateway. Whenever you go to the internet, you have to go to the router or the gateway. And so see, if you communicate from the 192.168.1.10 to the 192.168.1.11, they are on the same network here. Right? They are on the same network. They just directly communicate together via the switch. You don't have to involve the router here. But see, if you want to go to the internet, you want to go to the cisco.com, they think about we have the 170.10.10.10 here. I just make it up. So whenever you see, if you want to go from this IP address to the 170.10.10.10, it is an internet here, right? So you have to go to the gateway. Whenever you go to internet, you have to go to the gateway. And the gateway here, the gateway is the one who translated. You have translated from the private IP address to the public here. The thing about he have the public here is he have the public IP address is a 100 here, 100 here, not 100, not 100 here. Right? So he have to translate it from the IP address to the 100, 100, 100, and 100, and he deliver it to the 170.10.10.10. Right? So when this guy receive it, he send it back to the 100, 100, 100, 100, go to the router, and router knows that this one matched it with the 192.168.1.10 here, and he delivered to the 192.168.1.10. Now, the question is that if you match from 1 to 1 here, you don't set any IP address, right? You see, if from 1 to 1, you don't set IP address, you don't set any IP address. But when you work with the port address translation here, it helps you to set IP address here. So think about this. In the case of port, they use the port definition here, right? So you have the same IP address here, 100, 100, 100, 100. But you can use a port number 10 for the IP address number 10. He uses a port number 11 for the IP address of 11, and he uses a port number 12 here for the IP address of 12. So see, you only need one public IP address here, but you can use a multiple port to handle for multiple private IP address here. That's why you save a lot of IP address. Okay, it makes sense. Hello?
Yes, it makes sense.
Yeah.
Yes, yes.
Now see, now if you look on this example here, if you look on the example here, you only have one public IP address. Sorry, what is it? You only have one public IP address here. You only have one public IP address here. You see, all of them the 44, 44, 44, 44. But at the same time, this guy here is able to handle for multiple private IP address here. 20, 21, 22, and 23. And the reason that he able to handle it because he can separate by the port number here. Port number 8000 used for this guy, 8001 used for this guy, and so on here. And that's why you save a lot of public IP address when you use the private IP address here. And remember, when you communicate from local to local, you don't need to involve the router. But anytime, if you want to go to the internet, definitely you have to translate it to the public IP address here. And the one who do it is the gateway or the router here. It's the one who translate from the private IP address to the public IP address here. Okay, so that is an example in the case of the same network here. Remember that for the IP address, you have the two portions. You have the network portion and you have the host portion. So if two computers have the same network portion, they are on the same network. So if you look on this one here, if you look on this guy here, you can think about this one is the network portion. Both of them /24, that means you have the 24 bit in the network portion. And this one also 24 here. You have 24 bit in the network portion. So we see the PC1 and FTP server here, they have 192, 8 bit, right? You have the 116 here, so 168 here, 8 bits, and you have number 1 here, 8 bit. So the first 24 bit here, they are 192, 168.1. They are the same. They are same, that means they are on the same network. So we see, in the case of the same network, the two computers that directly communicate together. In that case, that communicate by the switch here. So we see, when you put it in the process of encapsulation, right? You have to put the IP address here. IP address 192.168.1.110 here. It is a source, and 192.168.1.9 here. It is destination here. You have the source here. You have destination here on the same network. Right? You see, they have the same network portion. That's why they are on the same network. So in that case, you directly communicate together. That's why you put this one is a source MAC address here, and this one is a destination MAC address here. Right? That is the encapsulation. In the case of the same network, users directly communicate together here. Okay. Now, what happens if you are not on the same network? What happens if you are not the same network here? Sorry, one more thing I have to tell you that the MAC address here is only used on the same network only. The destination here, the destination only used on the same network. So we see in the case user, in the case you send from this guy to here on the same network. Right? That's why you have the destination here and you have the source here. It's very simple in the case on the same network here. Now what happens if you are not on the same network? If the destination, if the final destination not on the same network here. Now think about this one. Think about this one here. I am the source here, 192.168.1.110, and here's the destination, 172.16.1.99 here. I want to go from this guy to this guy. And if you look on the topology, they are not on the same network. They are not on the same network. It's very simple. You can see it. And also, if you look from IP address here, that is the network portion, and that is the network portion. They are not the same. They are not the same. So this guy here, he want to deliver to the 172.16.1.99. The first step, you only have to figure out if the destination on the same network or not. If on the same network, you just directly communicate together. You put the final destination MAC address is the same with the final destination MAC address here. Right? But in the case here, the first step, you know that the destination here is not on the same network. So in the case of the not on the same network, you have to remember that you always have to deliver it to the default gateway. Default gateway, that means the router, the local router here. Right? So see, the first step is that you only have to deliver it to the default gateway here. you only have to deliver to default gateway in the case of remote network, right? So see, even this guy here, if he want to send here, he also have to go to the default gateway, and this guy also, he have to deliver to the default gateway. That is the first step of remote communication here. It only applies to everyone, right? So see, all of them here, they are on the same network. They must have the same default gateway, and the default gateway is the interface IP address of the local router here, right? So you see, whenever you deliver to this guy or this guy here, the first step here, you always have to deliver to the default gateway, right? So you see, what happened here? The IP address, it keeps the same, right? That is original IP address here, and the IP address of destination here, it is a final IP address of destination. But you see, the destination of the source here is not the destination here. It's not this guy. The destination here, it is a MAC address of the default gateway, because you see, the MAC address is only on the same network only. The final MAC address only on the same network. It makes sense. I know it's quite complicated here, but you have to think that the source and the destination MAC address only on the same network. Only on the same network. Right? So see, whenever this guy here remote, you know that for sure. The first step, you only have to deliver to the default gateway. So when you deliver to the default gateway, you've done the job. And from now on, the router is the one who who tell you which way to go here. From here to here, from here to here, and from here to here, and so on. All right. So remember that in the case of the MAC address here, the source and destination only on the same network. In the case of the same network, directly communicate together. In the case of remote network, the first step you have to deliver to the default gateway. So we see instead of encapsulation, in the case of in encapsulation here, the first step, figure out the destination, the source and destination here not on the same network. So in the case, you know that you for sure. The first step you have to deliver to the default gateway. That's why you see you have to push the MAC address of the default gateway as a destination, and the source is down here. That is the first step. You deliver it to the default gateway here, router. Now, what's next here? Remember here. Remember it for the layer 2 address here. Layer 2 address here. It only works on the same network, right? You see, only same network here. So here on the same network, and here on the same network here. So what happened here? You think about this guy here. The MAC address is A here. And this guy here, MAC address is B. And this guy here, MAC address is a C. And this guy here, MAC address is D. And this one here is E. And this one here, F here. So here's the process of encapsulation. You see, the layer 3 address or IP address here always stay the same. It never change during the whole process. But the layer 2 address here, it change step by step, change step by step, change step by step. You see, right now you have to put here, source is A, and destination B here. So when we send to the router is the one who tell you which is the best way to reach the destination. And he knows that in order to reach final destination here, he had to forward to the another router here. And you know that he knows that in order to deliver to another router, he have to change the layer 2 address here. So now this guy here, the source is a C, and the destination here D. Okay, and so on. So when you go to this side, the source here is E, and destination here is F. And remember, the layer 2, 3 address always stay the same, never change. But the layer 2 here, it change step by step, change step by step, change step by step. It makes sense?
Yes.
Yeah.
Okay, let me give you example here to make it more simple here. Think about this one. You are the guy here in Bloomington. You want to send a letter to your friend. You want to send a letter to your friend. So of course you have to name this guy here A. This guy here A, and he live in the 110 street here, and Bloomington here. And this guy here, name his, it can be here. B, and he lived in the 220 street and Chicago here, to make it simple, right? So see, in order to deliver the mail here, from this guy to this guy here, he have no idea of the whole way to go to the guy B here, right? The only step he knows that he have to deliver it to the Bloomington USPS here, right? That is, I can think about this. This is the gateway. You know for sure that in order to send it to anywhere outside Bloomington, the first step you have to send it to Bloomington USPS here. So we can think about this one, the gateway here, the gateway, right? So see, this in order to deliver it from this guy to this guy here, the first step you have to send it to the USPS Bloomington. You can think about this guy here, the C, right? The C. So we see you have to put the envelope here from A. You send it to the C, and of course the IP, the address here, you only have to keep the same. You only have to keep the same. From 100 here, you send it to 100. So now when you go to the USPS Bloomington here, he knows that in order to deliver to the Chicago, you can think about this router, right? You have to figure it out. In order to deliver it, you have to deliver it to the USPS Indianapolis here. So now this guy here is the C. Sorry, this guy here is the D, and this guy here is E. So we see, now we have to change it here. You have to put this guy here as a D, and this guy here, it is E here. And of course, you see, this one it never changed, but this guy here, it changed step by step. That make more sense? And so on. That's why the layer 3 address never changed, but the layer 2, it changed step by step, Well, now you go with the IPv6. Remember the IPv6, you have a 128 bit, and you break it down. Into 8 group, 8 block here. Each of the block is a 16 bit. You see, you have, if you look on this one here. You have 1, you have 2, 3, 4, 5, 6, 7, and 8. All right. So we have 128. You divide by 8 block. Each block you have the 16 bit here. That's why each block you have the 16 bit. And in order to represent the 16 bit in the hexadecimal, you need the 4 hexadecimal here. You need the 4 hexadecimal. Right? And of course, if you look on all of the hexadecimal here, it's sometimes very long for you to look on that. So we have some way to compress IPv6 here. They change here. So anytime you have the continuous group of 0 here, you can replace it by double column here. You can replace it by that column. So you see, you can replace this one here, 0 here, double column, or you can replace this guy here, double column. But remember, you only able to replace it by one time only. You cannot do it more than one time. Otherwise, very, very confusing here. Okay. So if you look at this one here, 1, 2, 3, 4, 5, 6, 7. You only have the 7 group. Right? So we see this one here, it only have one group of 0 here. But when you look at this one, 1, 2, 3, 4, 5, 6. Actually, you need the 8 group, but here you only have a 6 group. So we know that double column here, actually you have 2 group of 0 here. That's why you only able to use this for one time only. Otherwise, very confusing. You do have no idea how many group of 0 on this one and how many group of 0 on this one. Okay, for the IPv6 terminology, you have some definition. You have the link. The link, that means you have on the same local network here. So you can think about when you have the router here, right? I think you have the network, you have the router. Remember that each interface router is one network. Right? So for the one network, you connect to the switch. And from the switch, you connect to the multiple computer here. All of them, they are on the same network. Or they code on the same link here. The link in the IPv6, you can think about this, they are on the same local network here. Right? And the neighbor are 2 or more nodes on the same link. So we see this guy and this guy is a neighbor, or this guy and this guy is neighbor, because they are on the same local area network here, link here. Alright, and you have the dual stack. Dual stack, that means you able to work at the same time for both of the IPv4 and IPv6 here. They call it a dual stack. And tunneling is a method used by the IPv6 to transport the IPv6 packet through the or over the IPv4 network. Let me give you an example about the tunneling here. Yeah, think about this. You have the network here. You have the IPv6 only. And this one, this network here, you also have the IPv6 only. So you can think about from this computer here in the IPv6 network only, and the computer here, so in the IPv6 network only. But in order to communicate from this guy to this guy here, you have to go to the network, and this network here is only support for the IPv4 only. So in that case, you have to work with tunneling. Tunneling is that what that you have the packet here. You have the packet IPv6 here. Come from this guy, right? So in order to deliver to IPv4, you have to encapsulate it. You have to put everything inside the IPv4 network. Right? So we have to put it here in the packet of IPv4 network. Right? So when you send it from the IPv4 network, you send it from here to here, you have to put it in the IPv4 network. So when you go to the destination here, destination knows that he have to open the envelope, strip it off, and send it to the IPv6 here. That is the tunneling in the IPv6 network. Right? Remember that tunneling is that when you connect from the IPv6 network only to the IPv6 network only. But in order to do the communication between them, you have to do with the IPv4 only. So in that case, you have to put the whole packet of IPv6 inside the IPv4 network here. Okay, and you have the definition of interface ID. Interface ID is the same with the network portion in the IPv4 here. In the IPv6, it breaks it down into two portions. You have the interface ID here. Sorry, you have network interface. Interface. Yeah, you have the interface ID, and you have the, what is it? I forgot. Is this one is a network. Sorry, this one is called the prefix. Sorry, my prefix ID. Prefix ID. So you have the 64-bit of the prefix ID, and this one you have the interface ID here. And you have the 64-bit also. So we can think about the same with the IPv4. You can think about this prefix ID is the same with the network portion. And the interface ID here, you can think about the whole portion here in the IPv6. Sorry, in IPv4. Okay, and you have the sum of definition of unicast address. Unicast address is a specify a single node on the network. You can have a global address. Global, that means you can go to anywhere on the internet. That's a global. Or link local. Link local is the same with the private IP address in the IPv4. That means you only contain in the link local network only. You cannot go to the global network. And anytime you want to do that, you have to use a global address here. And the loopback address is used for the testing purpose only, for the testing purpose. And you have the multicast address also. Multicast address deliver packet to all of the nodes on the same network, on a network. And you have anycast address. You can identify the multiple destination which packet deliver to the closest destination. So you can think about when you think about anycast here, you can think about this one here, right? So you can think about if you want to go to the Google, right? Say whenever you go to the Google here. So whenever you go to google.com, actually you see the google.com, it have more than one server. It have the many server here. So maybe one in Chicago, one in the St. Louis, or one in San Francisco. All of them group them together. They call it is a cluster here. So we see whenever you enter one wide web google.com, the computer figure out which is the closest server you go, right? So from here you can think about from Bloomington here, you know that in order to go to the Google server here, you route it to the Chicago server here. Even that all of them here, they might have the same cluster here. And the any kind of address is the one identify the multiple destination. You see, you can have a multiple destination here, but it know which one is closest to you. And so we deliver it to the Chicago here. Any questions so far? Hello?
No.
Okay. So now you can think about the global IP address here. Remember the global as well as the IP6, they break it down with the two portions. This they call this one is prefix ID. Prefix ID. And the second one is the interface ID here. So in the case of prefix ID, the first in the case of global address, remember that global address is the one who route to anyone in the internet here. It's routable, right? It go. And in the case of global address here, the first 3 bit here, the first 3 bits is always 001. It's always 001 here. Right? So we see when you group 4 bits together, the first 3 bits always 001. So sorry, 001. And the last bit it can be 0 or it can be 1 here. Right? So when you convert the 4 bit here, it can be the number 2 or number 3 already. That's why when you see the global address here, it always starting from the number 3 or number 2 already. And also the next thing you have the global routing prefix here. Routing prefix is provided by the internet service provider. And for the 16-bit here, it's the subnet ID. Subnet ID that means you can break it down into multiple networks. So you can break one network for the IT department, you can one network for HR department, and so on. And this one is a 64-bit here. It is an interface ID. It's type of the Unity identifies what is your network interface card here. And in the case of link local, the link local, remember that link local is the same with the private IP address in the IP4. It only routable inside the network only. You cannot route it go to the internet here. All right. So you can see everything FE80 //24 here. It's a link local. And the loopback address. You have the number 1 here. It is the purpose for the testing to make sure that the computer works perfectly with the IPv6 or not. Okay, so we can check. You can anytime if you want to check the configuration, you go to the command prompt. You put the IP config here, right? You see when you have put the IP config, you have the information here. Right? For this IPv6 here, you have FE. You see, sorry. See, you have FE80 here. That's the link local. All right, and also you have the IPv4. You have the subnet mask. Right? This one also, you have the link local IPv6 here, and so on. Okay, now for the IPv6 address, you also use you have the IPv6 auto compression. That is the benefit of IPv6. It's very easy with the auto compression here. Right? The IPv6 address is designed so that a computer can auto configure its own link local address here. Remember here, in that case, it's very easy to configure the whole link local IP address. So we see when user have the 2 computers with the IPv6 enabled, when you plug them together with a physical cable, they can directly communicate together because they can generate their own link local here, and they can communicate locally together with the link local address. As they call it, it is a slack here or static address or auto configuration here. and the computer can create its IPv6 address. It uses the FE80/64 as the first bit of prefix here. Right? Remember that for the 128 bit, you have the first 64 bit. It is a prefix, and the second 64 bit is the interface ID here. Okay, so in the case of generated here, in the case of generate, right? In the case of generate, the linear code address is generated here, FE80 here. And the second one, it got it from the MAC address. It got it from the MAC address, or it got it from the network interface card here. Okay. Now come back with right. So we see for this one is 64 bit, and this 64 bit here, it can get it from the MAC address. Now, remember how many bits you have for MAC address? How many bits you have for MAC address? What is it?
60.
How many bits you have for the MAC address?
148 or something, 128.
Now I'm asking about, yeah, MAC address here is the 48 bit. Remember, right? The MAC address or physical address, you only have the 48 bit. You got it? That is a no, I think this one. Okay, so see, that is a physical address or MAC address here, right? Now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have the 12 hexadigit. That means you have the 48 bit here. Right? That is the format of the MAC address. You have the 48 bit. Yeah, 48 bit for the MAC address here. Now you see, for the interface ID here, you have the 64 bit. Sorry. For the interface ID, you have the 64 bit, right? And you can generate it from the MAC address. MAC address only has a 48 bit. So we see, you still need more 16 bit here. You still need more 16 bit here. Right? Okay, this one is 48, right? And in order to make it up for the interface ID, you need the 64 bits. That's why you need more 16 bit here. So normally they work it right here. They break it down. The first 6 hexa here, right? And the second 6 hexa here. Right, so see, 6 and 6, you have the 12 hexadigits or 48 bit here, right? And the insert between them, is E here. Now see, you have 1, you have 2, you have 3, or 4 hexadigits. That means you have the 16 bit here, 16 bit here. So see, you have this one 24 bit, this one 16 bit, and this one 24 bit. You add them all together, you have the 64 bit here. Okay, so normally the last 64 bit here, you can generate from the network adapter MAC address by insert FE between the first 6 hexadigit and the last 6 hexadigit here. Okay, and the computer, as if a router on the network provides the configuration, the process is a router solicitation process here. So whenever you power on the computer, it send it out the router solicitation message to ask router here. I want to configure the IP address automatically by myself. Now, let's check here. Which of the following IP address is a public IP address? What do you think? If you look on this one, which one is the public?
B.
Which one is the public?
Is it B?
Okay, so
C, right? D.
Wait, no.
Okay, now tell me which one.
D, because 10, 172, and 192 are all private.
Yeah, right. So in order to tell which one is public, you have to tell which one is private here. And remember that you have the three ranges of private. You have the three ranges of private here. The first one is the 10. The first one is 10 of everything here. The second one is the range from 172.16 come to the 172.31. And the third one is 192, 168.actually. So see, this one here, private, right? This one here, private. This one here, private. So only this guy here is the public. It makes sense?
Yeah, that makes sense.
Okay. Now, we talk about the port and socket. Remember that the reason you use the port because you want to separate to know which traffic it belongs to, right? Same that you think, right? You only have one physical connection to Ethernet, but at the same time, you can go to the one-way web service or email service here. And you have to use the definition of port number to know which service it is. Right? The port number is assigned, it's a process that can receive the data. The port number ensures the data is transmitted to correct process among the multiple process running on a single device. Okay, sorry. A socket consists of ports, IP address, and the port number. That's not the first definition is the port number. The second one is socket. Socket is a combination of both IP address and the port number here. Now see, this one is the IP address, and this one is the port number here. Right? So you have the port number 23 is the telnet service here. Right? And the port number is divided into three types. The first one is a well-known port. In the range from the 0 to 1023. The second one is a register port. You have, if you want to use it, you have to register it. And the third one, dynamic and private. You can generate by your own computer here. All right. Okay. And you see when you communicate together, right? If you want to, it's a virtual connection. In the case of remote access with the telnet here. Just think about you want to from the client here. He want to remotely access to the server. So we have to send the request for the telnet connection on the port 23. And this one acknowledgement for the connection is the port 23. And the reason that you know this is the telnet service, because when you look on the port 23 here, it is a well-known port in the range from 0 to the 1023. So when you see port number 23, you know that is a telnet service here. And here is a list of the sum of the well-known port. So see, whenever you see the port number 2021 in TCP here, it is for the SPI transport protocol. So we have the 22 here, it's for the CPU shell remote access. For the 23, it's a telnet, and 25 is for the email, and so on. That they are the well-known port. And normally, when you look at the number of the port, you can instantly know which traffic it is, which process it is. Now we talk about the domain name and DNS here. So to make it simple, you have to whenever you think about this one here, for every computer, for every communication on the internet here, for every communication on the internet, you need to involve the IP address. You need to import the IP address here. So think about this one here. This one is a cisco.com server. Cisco.com server. So see, in order to go to cisco.com server, right? So in the browser here, you just enter the World Wide Web. Cisco.com. So hit the enter. Actually, what is the process here? In order to deliver it to the cisco.com server here, it had to translate it to the IP address here. So you can think about it, you have to translate it to 70.10.10.10 here. Because the computer here, ultimately it had to convert it into the IP address here. So you see, instead of enter the 170.10.10.10, it's very hard for you to remember the address here. Instead of using the one web cisco.com, it makes you way easier here. when we use the number here. That's why the use a uniform resource locator here. It is a addressing scheme that identify where to find the particular resource originator. So see, whenever you enter the World Wide Web Cisco.com, actually it have the process to convert it into the actual IP address here. And the process is the code is a DNS here. DNS is a domain name service. It converts everything from the URL here into the actual IP address here. Now let's watch a short video here. Make it more sense.
You want to be an IT pro, so you must have all of these tools. Remote monitoring.
The root servers are computers don't go by names like humans do. They go by numbers. Because that's how computers and other similar devices talk and identify with each other over a network, which is by using numbers such as IP addresses. Humans, on the other hand, are accustomed to using names instead of numbers. Whether it's talking directly to another person or identifying a country, place, or thing, humans identify with names instead of numbers. So in order to bridge the communication gap between computers and humans and make the communication a lot easier, networking engineers developed DNS. And DNS stands for Domain Name System. And DNS resolves names to numbers. To be more specific, it resolves domain names to IP addresses. So if you type in a web address in your web browser, DNS will resolve the name to a number, because the only thing computers know are numbers. So for example, if you wanted to go to a certain website, you would open up your web browser and type in the domain name of that website. So for example, let's use yahoo.com. Now technically, you really don't have to type in yahoo.com to retrieve the Yahoo web page. You can just type in the IP address instead if you already knew what the IP address was. But since we are not accustomed to memorizing and dealing with numbers, especially when there are millions of websites on the internet, we can just type in the domain name instead and let DNS convert it to an IP address for us. So back to our example, when you type in yahoo.com in your web browser, the DNS server will search through its database to find a matching IP address for that domain name. And when it finds it, it will resolve that domain name to the IP address of the Yahoo website. And once that is done, then your computer is able to communicate with the Yahoo web server and retrieve the web page. So DNS basically works like a phone book. When you want to find a number, you don't look up the number first. You look up the name first, then it will give you the number. So to break this down into further detail, let's examine the steps that DNS takes. So when you type in yahoo.com in your web browser, and if your web browser or operating system can't find the IP address in its own cache memory, it will send the query to the next level to what is called the resolver server. The resolver server is basically your ISP or Internet Service Provider. So when the resolver receives the query, it will check its own cache memory to find an IP address for yahoo.com, and if it can't find it, it will send the query to the next level, which is the root server. The root servers are the top or the root of a DNS hierarchy. There are 13 sets of these root servers, and they are strategically placed around the world, and they are operated by 12 different organizations. And each set of these root servers has their own unique IP address. So when the root server receives the query for the IP address for yahoo.com, the root server is not going to know what the IP address is. But the root server does know where to send the resolver to help it find the IP address. So the root server will direct the resolver to the TLD or top-level domain server for the .com domain. So the resolver will now ask the TLD server for the IP address for yahoo.com. The top-level domain server stores the address information for top-level domains, such as .com, .net, .org, and so on. This particular TLD server manages the .com domain, which yahoo.com is a part of. So when a TLD server receives the query for the IP address for yahoo.com, the TLD server is not going to know what the IP address is for yahoo.com. So the TLD will direct the resolver to the next and final level, which are the authoritative name servers. So once again, the resolver will now ask the authoritative name server for the IP address for yahoo.com. The authoritative name server or servers are responsible for knowing everything about the domain, which includes the IP address. They are the final authority. So when the authoritative name server receives the query from the resolver, the name server will respond with the IP address for yahoo.com. And finally, the resolver will tell your computer the IP address for yahoo.com, and then your computer can now retrieve the Yahoo web page. It's important to note that once the resolver receives the IP address, it will store it in its cache memory in case it receives another query for yahoo.com, so it doesn't have to go through all those steps again.
Okay, so if the thing about DNS is a kind of the directory book, right? You have the database to translate. Have the database to translate from. You have the database to translate from the World Wide Web address. Translate from World Wide Web address to actual IP address. And in the DNS is a domain name system or service. It's an application layer, client server. That means you see whenever we enter the World Wide Web here, if you don't have if your computer does the translation between the World Wide Web address and actual IP address in its local cache, you have to query to the DNS server. Right? So we have to work in the application layer, client server system here. And we have made up of this element. The first one, the namespace, it's an entire collection of a computer name and the associated IP address stored in the database on DNS name server around the globe. And the second one, you have the name server. It's a whole database which are organized in the hierarchical structure. We'll talk about how it works at the hierarchical structure later. The third one, is resolver. It's a DNS client that requests information from the DNS name server. Okay, and each organization that provides a whole service is responsible to providing and maintain its own DNS authoritative server for public access here. And the authoritative name server is authority on the computer name and the IP address for the computer on their domain here. So you can think about this one here. The domain that the organization is responsible for managing the core DNS zone. So we can think about. Let's think about this one here. Here, you can think about IPtech here. IPtech.edu. That is also a domain name here, right? So, in order to do that, you have for the IPtech community college here. You have the DNS. You have the DNS. You have to maintain the DNS server here. So every computer inside the IPtech campus, in the IPtech network here. The first step, if you enter anything with the World Web here, the first step, you will query to the DNS server of IPtech. the query to the NETI IPT server of IPTech here and check what is think about what is the IP address of the cisco.com here. So for this guy here, he maintains the local he maintains the database. I maintain the database for this one. But sometimes he's not updated or he don't have, you have to escalate it. You have to escalate it into the EDO level here. And so on, you have to escalate it into the top level here. And root level here. Now, let me go back to this one here. You have the 4 common type of DNS server. The first one, the primary DNS server, it is authoritative name server for organization. And it's whole authoritative DNS database for organization zone. And the second one, the secondary DNS server, it's a backup authoritative name server for organization. I see this one the primary here. This one the primary, and this one secondary. That is the used for the backup. Right? This one is used for backup here, and they always sync. They always sync together here. Sync together. So in the case of primary going down, you have the update of database of the secondary here. Right? The third one, you have a caching DNS server. Caching is access the public DNS data and cache DNS information. It collects. I think about. So we think about you have the IPTech. You have IPTech DNS server here. Right, so the first time here you see, or the first time you enter you enter Yahoo.com, right? Yahoo.com. So the IPTech DNS server, he checked local database. He checked his database here. If he don't have any IP address of the Yahoo.com, right? He have to escalate it to the top level. It is EDU here, right? And EDU even that don't have it, it's escalated to the top level here, as a root level here. So when he got the IP address from Yahoo.com, think about 170.10.10.10 here. He stored in the database in the cache here. He stored in the 170.10.10.10. It's matching with the Yahoo.com here. Yahoo.com here, right? So see, the next time here, another computer he queried to the DNS server of IPTech. He know for sure that Yahoo.com is matching with the 170.10.10.10. He don't have to query it anymore. Right? So we see it saves a lot of the network resources here. Right? So it reduces the time of query and it saves a lot of bandwidth. You don't have to escalate it anymore. And you have the forwarding DNS server. It's receive the query from local client, but doesn't work to resolve the query here. And any of the DNS server type can coexist in the same machine, and DNS name server are organized in the hierarchical structure. You see in the diagram how it works with the hierarchical structure here. And as a root level, you in the global where you only have the 13 cluster of the root DNS server with. Okay, so here's how it works with the hierarchical structure here, right? So we see at the top you have the root here, then DNS root level here, root server, DNS root server here. You have only about 13 cluster server. And below that, you have the top level. You have the top level domain here. It can be .com or .org. It can be .edu or .gov or something like that. They call it a top level server. And you see, you have the authoritative server also, right? So you can think about you have ivtech.edu here, right? So see, edu here is a top level domain. And for IPTech, you have the authoritative server here. And of course, you can break it down furthermore, right? You can break it down furthermore. You can have the IT school, or you can have the nursing school here. You can break it down furthermore based on hierarchical structure here. Okay, so here, if we see how is the process of the when you query is name resolution for World Wide Web mdc.edu here. So normally the first step here. Normally, what is the first step? Normally, in the first step, when the user enter World Wide Web here, World Wide Web mdc.edu. Actually, the first step is always look at the local cache of your computer. It's local, DNS local, DNS local cache. So you can check the DNS local cache by the command you have. You can check it by the command here. IP coverage. DNS. I forgot it. DNS. Here. Yes. Now, let me check it. Okay, sorry, display DNS. Display DNS. Okay, so you see, if the first step is always it look it up. The first thing is that it look it up in the local DNS cache in your computer here, right? So you think about if you want to go to .google.com, you know for sure that is just root it to the 142.250.191 and 206 here. Right? That is the first step in the process of DNS query. So whenever you enter the World Wide Web something, the first step is look it up in the local DNS cache. Right? So you have the database here. You have a long database matching between the IP address and the World Wide Web address here. Right? So that is the first step. Remember that is the first step. Now, after you look it up in the local cache, you don't find it. You don't find it. You have to route it to the local DNS name resolver here. You have to escalate it to query, and you have to query to the local DNS resolver. So you can think about your IPTech community here. It routed up to the DNS server of IPTech. And if you work from the home local, if you work from the local network or home network, you can route it to the ISP DNS server. It can be the Comcast, it can be the IP address of the DNS server of Comcast or Xfinity or AT&T. It depends on what internet service provider you are, right? So now the first step here, you see, the first step here is route it to the local DNS and then resolver. You can think about this one is the IPTech DNS here. Right? So the IPTech DNS here, it route it to the so second one it route it to the root DNS and name server. Right? So it always step by step here, right? So when we come it back, you check for the DNS name server for EDU here, the top level, right? The top level here. The top level again, top level don't have it, right? Or it's top level is send it back, right? Send it back to you. You have an authoritative DNS name server here for MDC at you here. That is the one who handle everything about this guy here. One way happy. Right? For each organization, you always have a DNS authoritative DNS server here. So it's always working on the process that you see. Think about this one here. Where is it? Right? Think about this one guy here, right? This guy here, the first one you have to route it to the DNS. DNS go to the root, right? Forward it to the EDU, and the EDU is forward it to the MDC here. That is the process of the DNS query here. Any question?
No, I'm good.
Okay.
No.
So just remember that you have a long process in the DNS query, right? You have to working on hierarchy structure here. So we think about you are standing from the guy here, standing from the guy in the Microsoft. Right? So first step, you have to route it to the organization DNS. DNS go to the top level go to the root, right? Root here forward it to the EDU, and EDU knows that is a you have to forward to the MDC. It's an authoritative server here. And from that, you can have the IP address of the World Wide Web MDC edu, and you return it to this guy here. Okay, so you have the way of resolution process can get more complex. Caching server typically not the same machine as the authoritative server. Caching is sometimes it's out of date. You see, it's not always a real time here. It's out of date, so sometimes you have to take the action to get an update here and get it synced with the real time. Right? And sometimes the name server within the company might not have access to the root server. Right? And the top level a domain name server might be aware of intermediate name server rather than the authoritative name server. And you have the two types of DNS query. Sorry, you have the two types of DNS requests. The first one, recursive lookup. Recursive lookup is a query that demands resolution or the answer it can be found. So whenever you send the recursive here, lookup. Whenever you send the recursive lookup here, you either got the IP address here. Say you have the 173.10.10.10. You got it. Or if it's not able to find it, you got the answer here. It cannot be found. It cannot be found. It can be found here. Or the second one is iterative lookup. It's a query. The local server is a query to other server. But this one here, it provides the other server provides information. It has it. If not, you just ignore it and do nothing here. It not demand for a resolution here. Okay, so we have the sum of several types of the record. They call the record kept in the DNS database. The first one is start of authority record. It gives information about the zone. I think about the IP tag here. The second one, address here. The most two common record. You can see the most two common record. You can see it is A and quarter A here. So A here it is store the name address mapping to a host. This one work with the IP version 4. And this one here, the whole the name to address mapping is one with the IP version 6. IP version 6 here. Or it can have a CNAME, it holds alternative name for host, or it can have a pointer record for reverse lookup. Reverse lookup, that means you have the IP address here. You have IP address, but you don't know what is the World Wide Web address. That is reverse lookup. You can have the as or name server record, indicates the authoritative name server or domain. You have the mail exchange records, identify the mail server and issue email traffic here. And you have the service record and you have the check record also. But the most two common you can see in the DNS is A and I think it's a quadri A, right? The A is a whole between the mapping between the World Wide Web address and the IPv4 address. And the quarter A here, you have the whole the name to address mapping between the World Wide Web address and the IPv6 address here. Okay, and you have the DNS server software. The most common one is the Berkeley Internet Domain Server here. Name domain here. It's the most popular DNS server software. It's open source. And it's a built-in DNS service in the Windows Server web. So when you have the Windows Server, it already has the built software for the DNS server here. Okay, now I think it's done everything with the IP address, MAC address, port number, and DNS here. So now we have some of the very basic troubleshooting address a problem here. The first thing is that the first thing when you have any problem come up, you always should check with the event viewer here. Right? So in the event viewer, you can see what is severity of the alarm, and you have information what is the root cause of the alarm here. Now think about it here. You have the sum of the general information and the detailed information here. So and you have the severity of the alarm here. So we have this one. You have the error, and sometimes you can find the warning or critical here. Okay, so some of the most common tool it tests the connectivity is the ping here, right? The ping here. So you see the ping is already, you can open the command prompt and you can ping it. The ping it can be As the thing is ICMP message here, Internet Control Message Protocol is the protocol used by the echo request. So whenever you ping to the destination, and you suppose that you got the response from the destination here. So if you got the response, you understand that the connectivity is going well here. Okay, and you can have the ping 6 or ping /6 here when you work with the IPv6 here. And also that command is very, very common here. The IP config or IP config /o. You have a lot of information when you work with the troubleshooting here. So the ping command is the most common command when you test for the connectivity, right? So I want to ping to the google.com. Make sure I'm able to ping to Google or not. And then working well here, right? And the second one is that you can, when you work with troubleshooting, you have a command here, IP config here. So in the IP config, give you some of the basic information. Basic information here. You see, you have the link local IP address here. That's the link local IP address, right? And you have the IP version 4 for my computer, and the subnet mask and the default gateway. Remember, the default gateway it is a local router. Whenever you go to beyond the network, the first step you have to send it to the default gateway here. Right? So normally in the case when you troubleshoot the internet connectivity, the first step you have to make sure that you have no problem. You have no problem with your network interface. So in that case, you have to ping to the local here. You have to ping to the 127.0.0.1. So that is they call it the loopback IP address 127.0.0.1. It's a loopback IP address. So when you're able to ping to 127.0.0.1, you can understand that you have no problem. You have no problem with your network interface here. Right? So that is the first step. Now, next step, you have to make sure that you are able to ping it to the default gateway. So you see the default gateway here, right? You have the gateway here, so you ping it to the 10.2.2.1. So you see, when you are able to ping to the default gateway, you done the job, right? Because everything beyond the router is not your problem anymore. Sometimes it can be the internet service provider problem here. So we have to escalate it into the internet service provider. And you have some information about IP config and /o here. You have more information. Right? For this one, you see, you have information about physical address. You have the information about the IP version 4. You have the subnet mask. Right? You have the default gateway. You have DHCP server. We talk about what is DHCP server later. You see, you also have information about this one here. DNS server here. DNS server. Right? This one you can think about. This one is the DNS server from the IPsec here. Okay, so in the case you work with Unix or Linux here, you have the IP utility here. Right? And remember that in the case you want to build a TCP setting in the Linux, you have to use IF config here, not IP config. And NET lookup also. NET lookup is a kind of reverse and it's kind of the check the conversion from the one-way web address to the IP address here, right? So something about you want to make sure that you have no problem with the DNS, you can check it here. So NET lookup, see what is the IP address of Cisco.com. So I can see it here, right? I can see it converted correctly to the 172.163.4.1 here. Or I can look up to the google.com to see what I'm going on. Or you can have reverse lookup. You have the IP address, but you don't know what is the one-way web address. You can enter it here 72.163.4.185. Okay, so it return you this one. This one is Cisco.com here. This one is Cisco.com here. And added lookup is available in two modes. The first one, interactive, attach multiple DNS server at one time, and non-interactive can attach a single DNS server. Disk or domain information broker is available in the Linux or Mac OS. I don't have yes. Okay, so we have the sum of the common network issues. The first one, incorrect type, it's also very important here. So basically, if you work in the network, you involve many devices together. You only have to sync. You only have to sync them together in the time here. You can check the domain computer time, or you have the problem with the DHCP here. DHCP issue that means DHCP is that means you got the IP address automatically from the DNS server. You don't have to manually configure it. Right? So in order to go to the internet, you only need the IP address. And normally when you work in the company or when you work in the local network or the home network, you don't have to manually configure the IP address. You can get it automatically from the DHCP server here. So in some case, you have to check the DHCP server problem here, or you can check with you have to check if something wrong with the incorrect IP address or duplicate IP address or incorrect subnet mask, incorrect default gateway, incorrect DNS or DNS is the problem here. Okay, so I think that's all for the lecture for today. Any question from you?
I'm good.
Thank you. No.
So let me see what you have for the homework here. Okay, so here, the first step is the DNS query, right? That you have IP config and display here. Display DNS, that means you check the local cache in the computer. If you already have the translation from the World Wide Web address to the IP address, you just take it from the local cache. Right? You just take it from the local cache. Okay, and if you want to delete everything from the local cache, you can use the command here, IP config and flush DNS here to delete everything. And again, if you want to check it again, and you can display the net after the flush, you will have nothing in your DNS cache. Okay, so whenever you enter the sendgate.com or google.com, your computer also query to the DNS server, right? And once you got the IP address, it will store it locally in your computer also. So the next time you don't have to query to the DNS server anymore. You can take it from the local DNS cache in your computer. Okay, and anytime if you want to configure for the IPv4 and IPv6 manually, you go it's our computer here, right? It's your computer here. You go to the network and internet setting. You go to internet here. You go to change adapter option, and from there you can add the network interface card when you interface with the network. And in order to change the IPv4 or IPv6, you just right click on the property, and you can change the IPv4 here. I see this one right now it got it from DHCP server automatically, but you want to manually configure it, you click the option here, and you could do the same with the IPv6. Okay, so if you want to change the DNS manually, you can do it. So for this example here, you just change it to the from the your ISP DNS server, the IP address. You can change it to the Google here. The Google, that means the next time it's a query, to send it to the DNS Google server here. Okay, so when you have the IP config display, you have information, every information about IP address, the subnet mark, default gateway, DNS information, DHCP server, and MAC address also. You have display in the patch here. Okay, so I think that's not much work with this one. Let's see what else. Okay, this one here. This one you have to go to the book, right? Cascode 32, right? Okay, so for this one, you have to build the MAC address table in the package JSON. So in that's why you have to follow the process. You have to drag and drop the PT switch here. So we have to go to the package JSON first. And you follow this one. So with the network device, sorry. You go to the switch, you go to the PT switch. Okay, so when you go to the PT switch, click on this one, go to the command line interface here. That's where you configure for the switch. You hit enter. That is when you in the user exec mode. You have nothing to do with this one, right? So in order to go to the previous mode, you have to put enable here. Enable here. And if you want to configure for something, you have to go to the global configuration mode. You have to put it config terminal here. Config terminal. Now you are able to configure. So we can change the host name, or you do is some of the basic configuration here.